Good morning everyone. Today we will study about the assignment problem. In this assignment problem, suppose there are n jobs to be performed by the n persons which are available in the location. So the idea behind this assignment problem is nothing but which job to be assigned to which person so that we can minimize the total cost. That idea will be solved by using this assignment problem. This is the main mode of this studying this assignment problem. The mathematical form of the assignment problem will be like this. There are n jobs, n persons and m jobs, and the cost for one person to one job or one job to one person is C11. Similarly, for the first person to second job, it will cost about C12. These are the cost row wise and the column wise. This is the mathematical formulation of an assignment problem. Okay. Now, so again the assignment problem can be stated in a relation form. That is, mathematically the assignment problem can be stated as minimize z equals to summation of I from 1 to n, summation j from 1 to n, Cij into Xij. Cij is nothing but the cost to travel from one point to another point, and Xi is nothing but the location points. So j is equal to 1 to n and I equals to 1 to n. Subject to the constraint. Subject to the constraint in the sense it will have some conditions. Xij equals to 1. It indicates that ith person is assigned to jth job. If it is not assigned, in that case it will take the value as 0. If it is assigned, then it will take the value as 1. Okay, so the difference between assignment and the transportation problem, already we have studied about the transportation problem. We will see the main difference between these two. In the transportation problem, the number of sources and the destination need not be equal. They may or may not be equal in case of transportation problem, but in case of assignment problem, the assignment is made one-to-one basis, one-to-one mapping, in the sense one person is assigned for one job. So the number of sources and the destination must be equal. Hence the cost matrix must be a square matrix. But in case of transportation, it need not be a square matrix. But in case of assignment problem, it must be a square matrix. That is the first difference. Second difference, Xij indicates that the quantity to be transported from ith origin to jth destination. In this assignment problem, if I write Xij, that indicates that ith job is assigned for the jth person. Okay, either it may take the value 1 or 0. If it is assigned to ith job is assigned to jth person, then it will take the value as 1. If it is not assigned, then it will take the value as 0. That is the second difference. And third difference tells that in this transportation problem, the problem may be unbalanced if the total supply is not equals to total demand. Here the problem is unbalanced if the cost matrix is not a square matrix. If it is not a square matrix, in that case the assignment problem becomes the unbalanced square matrix. Here, and the last difference is nothing but the capacity and the requirement value is equal. That indicates that Ai and Bj for the ith source and jth destinations, they are equal. And here the capacity and the requirement value is exactly 1 if for the source of each destination of the capacity and the requirement value is exactly 1. In the sense, ith person is assigned to jth person, in the sense it will take the value as 1, otherwise it will take the value as 0. Okay, so these are the main difference between the transportation problem and the assignment problem. Now we will solve the assignment problem. In order to solve the assignment problem, we have to follow the some conditions or some steps. So this assignment problem can be solved by the Hungarian mathematician, and that name this method is known as a Hungarian method also. The first step tells that prepare a cost matrix. If the cost matrix is not a square matrix, then add a dummy row or the dummy column with 0 cost element. In the sense, we have to, if the given matrix cost matrix is not a square matrix, in that case you have to add a dummy row and dummy column which are having the 0 element. Suppose the cost matrix containing 1, 2, 3, 4, 5, 6. Here it containing 2 rows and 3 columns. It is not a balanced matrix now. In the sense, it is not a square matrix. So one row is deficient here. So in that case, you have to add a dummy row with the cost of 0 element. That is the meaning. If there is a deficiency of the column, in that case we have to add a 0 column for this matrix. Okay, that is the first step. Second step, subtract the minimum element in each row from all the elements of the respective rows. Okay, so whatever the elements are there in this element, whichever the least element is there, take that element and subtract that corresponding row from that. 1 minus 1, 2 minus 1, 3 minus 1, like this. In this row, 4 is the least element, so it is 4 minus 4, 5 minus 4, 6 minus 4, like this. And here it is 0. Okay, that is the second step. And third step, further modify the resulting matrix by subtracting the minimum element of the each column from all the elements, as like we have subtracted in the row wise. Now for the third step we have to subtract column wise also. Select the minimum element present in each column and subtract the corresponding column. The fourth step, then draw the minimum number of horizontal and vertical lines to cover all the zeros in the resulting matrix. Okay, we have to draw the minimum number of horizontal and vertical lines to cover all the zeros. Now next one is nothing but, after drawing the vertical line and horizontal line, let the minimum number of lines capital N. Now there are two possibilities. When we draw the minimum number of horizontal and vertical lines, there arises two cases. The first case is if capital N is nothing but a minimum, whatever the line you have drawn, that the number of line drawn in the cost matrix, and small n indicates the order of the matrix. If capital N is equals to n, where n is the order of the matrix and optimal assignment can be made, so make the assignment to get the required solution. If capital N equals to n, that indicates that optimal solution is reached, and then we can go for the required solution. If the second case, if capital N is less than n, in the sense the number of line drawn is less than the order of the matrix, then we have to move for the step 5. Step 5, what it tells, determine the smallest uncovered element in the matrix. So whatever the number of lines you have drawn in that matrix, whatever the uncovered elements are there, in that uncovered element you have to select the minimum element, and that minimum element you have to subtract from the uncovered elements. Okay, and the intersecting point is added with the that smallest element. Okay, next step 6 tells that repeat step 3 and 4 until we get the case 1. Case 1 in the sense capital N should be equals to small n. Number of lines, if it is equals to order of the matrix, then we have to stop our process. Otherwise we have to process again the same cycle. Step 7, to make 0 assignment, examine the row successively until the row wise exactly a single 0 is found. When you subtract row reduction and column reduction, row reduction in the sense select the minimum element in row wise and subtract it. So whatever the 0 you will get the 0. It may come as a 1 0 or 2 0 in row and column wise. If it is containing only 1 0, then you have to assign it and you have to delete column wise element. And if you are getting excess of 0, in that case you have to cross mark the remaining zeros. So repeat the step 6 successively until one of the following situation arises. If no unmarked 0 is left, then the process ends there only. If there lies more than one unmarked 0 in any column or the row circle, any one of the unmarked 0, arbitrarily we can unmark the 0 value and mark the cross in the cell in the remaining zeros. So assign only 1 0 and remaining zeros to be cross marked. We will take the example, then you will get the clarity about this. And the last step, thus exactly one marked circle 0 is in each row and each column are taken as a matrix value. The assignment corresponding to their marked circle 0 will give the optimal assignment. Okay, so whatever the steps we have studied here, I will take this in the example and I will explain you now. So here they have given the problem. Using the following cost matrix, we have to find out the optimal job assignment and the cost of the assignment. They have given the cost matrix here, or we can also call it as a payoff matrix. So here there are 5 persons are there and 5 jobs are there. So already it is a square matrix. No need to add the dummy row and the dummy column. The first step is cleared now. Okay, so check whether it is a square matrix or not. Already the given matrix is a square matrix. Second step tells that In each row and each column you have to identify the least value and you have to subtract it. Okay, so in the first cell the least value is 8. We can mark it by dot value. Okay, in the sense the first row is subtracted by 8. In the second row the least value is 9. Mark it. In the third row the least value is 4. Next one the least value is 6. The last one the least value is 12. Now what you have to do is that corresponding row is subtracted by that least value. This first row is subtracted by 8, second row is subtracted by 9, third row is subtracted by 4, fourth row is subtracted by 6 and fifth row is subtracted by 12. Okay, after subtracting whatever the matrix comes, rewrite that matrix here once again. So you will get the matrix like this. Now the first step, whatever the row wise you have taken, that step is known as a row reduction. Now we have to go for the column reduction. Column wise select the least value. Here the least value is 0. Here also it is 0. Here the least value is 0. Here also 0. Here also 0. In the sense when you subtract to column wise 0, you will get the same elements. So write that same matrix once again here. First step is checking the square matrix. Second step is row reduction. Then third step is column reduction. Okay, column wise you have subtracted. Then the fourth step in the sense, I will redraw this table once again here. 50803 06565 8 15 046 10 00 20 11 3078. So this is a table, whatever the after row reduction and the column reduction. Now the fourth step is draw the minimum number of horizontal and vertical rows, vertical lines, so that it covers all zeros. Draw the minimum number of horizontal and vertical lines. In the sense, in the first row it containing only 1 0, so allocate this value. When you are assigning the values row wise, you have to delete the column. Okay. Next, in the second row there are 2 zeros are there, not possible to assign it. Now go for the third row containing more than 1 0, leave it. Fourth row it containing only 1 0, assign this value. Since you are assigning row wise, you have to delete column. Now the last row it containing only 1 0, assign it and delete this column. Now assignment is completed along the row wise. Now start column wise. First column and second column already it is deleted, leave it. Go for the third column containing only 1 0. Since you are assigned column wise, you have to delete this row. Next one is there is no 0 remaining now. Okay, you have to cover all the zeros. So all zeros are covered now. Now next step is you have to count the number of line drawn, capital N. So 1, 2, 3, 4. So number of line drawn is 4, but order of the matrix is 5. So the first case, if n equals to small n, you have to stop the process. Here it is not possible. We are in second case, that is capital N is less than small n. So when capital N is less than small n, in the sense we have to process further, that is step 5. So step 5 what it tells is we have to select the least value among the uncovered element. Uncovered element in the sense 8, 15, 11, 3, 7, 8, 4, 6. Among these, whatever the least value is there, that value you have to take as x. X equals to, here the least value is 3. Okay. So after this we are having three process now. So what the three process here? The first step is whatever the value you have taken, that is the least value from this uncovered element, that is x equals to 3. This x equals to 3 is added for the intersecting point. In the sense plus x. Okay, intersecting point in the sense this is the position 8, 5, 0. These are the intersecting points. For these points you have to add x value. X equals to 3, that 3 value you have to add it. And then next is subtract that x from the uncovered element. For the uncovered element you have to subtract this x. in the sense 8 minus 3, 11 minus 3, 15 minus 3, 3 minus 3, 4 minus 3, 7 minus 3, 6 minus 3, 8 minus 3. Okay, this is a step. First, identify the least element from the uncovered element, then add that uncovered element number to the intersecting point and subtract that number for the uncovered element, and the elements on the lines, they are written as it is. Okay, elements present on the line, they are written as it is except the intersecting point. Okay, and this is this procedure. So according to this procedure, we will write the elements now. So I am redrawing the table once again. Just wait. Okay, so 5 is on the line, so write it as it is. 6, 5, 0, and 8 is the intersecting point. For the intersecting, condition is plus x is added. X equals to 3 is there, so 8 plus 3, 11. So 0, 3. Next is 0, 6. 5 is the intersecting point, so 5 plus 3 is 8. 6, 5. Now it is 8. 8 is the uncovered element. For the uncovered element, you have to subtract it. So 8 minus 3, it is 5. So 15 minus 3, it is 12 and 0. 4 minus 3, 1. 6 minus 3, 3. And next one is 10. 0. 0 is the intersecting point. So 0 plus 3 is 3. Then it is 2. 0. 11 minus 3. So it is 8. Then 3 minus 3, 0. 0. 7 minus 3, 4. 8 minus 3, 5. Okay. Again, you have got the modified cost matrix. So after modified cost matrix, once again you have to do the same procedure. In the sense, assign the values row wise and column wise. In the first row, it containing 1, 0. Since you have assigned row wise, you have to delete the column. Second row containing more than 0, leave it. Third row containing more than 0, leave it. And the fourth row containing only 1, 0, assign it. Since you have taken row wise, you have to delete this column. 1, 2, 3, 4, 5. Now the fifth row, it containing only 1, 0, assign it, delete this column. Now column wise you assign it, column reduction. So assign this value, row wise you can delete it. Now the last column, it containing only 1, 0, so assign it, delete this row. Now count the number of lines. Column reduction and row reduction is completed, and the number of line drawn is also completed. Next step, you have to check the capital N value and the order of the matrix. Order of the matrix, it is already 5. So number of lines drawn, 1, 2, 3. 3 vertical lines and 2 horizontal lines. So you got the order of the matrix is same equals to the number of lines drawn. So we have reached the to final assignment now. Now you have to write the conclusion. Okay, since the order of the matrix is equals to the number of lines drawn, we have reached the optimality. Now you can give the assignment, which job is assigned for the which person. So whatever the assignment we have done, that indicate that is assigned for that person. So here you can see 1. The first person is assigned for B job. Okay, so we can write the conclusion here. So jobs and the persons. So 1, 2, 3, 4, 5. Which person has to do which job, so that we can minimize the cost here. That we can conclude here. So first person is assigned for B job, and second person is assigned for E job, third person is assigned for C job, and fourth person is assigned for A job, and fifth person is assigned for D job. So if you assign these persons to this job, we can minimize our cost. So what is that cost? That can be calculated further here. So for that you have to go for the initial table. So initial transfer, whatever the table, assignment table they have given, that table we have to take once again in the matrix form. So here 1 to B in the sense 1 to B, whatever the value is there, that value you have to write here. So the first table, so 1 to B, the cost is, so 1 to B, the cost is 8. So you have to write its cost is 8. Similarly, 2 to E, the cost is 12 rupees. So write here 12 rupees. Similarly, 3 to C. 3 to C. The cost is 4 rupees. Next 4 to A. 4 to A cost is 6 rupees. 5 to D cost is 12 rupees. So all the cost you have written by seeing your initial table. Okay. So when you write all the cost, now you have to get the total cost. For that you have to add all the values. 8 plus 12 plus 4 plus 6 plus 12. So we will get the total rupees as 42 rupees. If you take the assignment help, in that case you can assign these persons for this job but in this minimum cost 42 rupees. If you, other than this assignment, if you assign one first person for A job, second person for B job, third person for C job, the work will complete, no problem in that, but your cost will be more as compared to this one. So in order to minimize the cost, we have to take the help of the assignment problem. Thank you.